Now we're going to learn about multiplication and division of rational expressions. So let's just review multiplying and dividing fractions. Remember, when we multiply two fractions, we use this property. If we have an a over b and we're multiplying it by a c over d, we just multiply straight across. A times c, b times d, so that we get ac over bd. Now to divide, change the division problem to a multiplication problem by using this property. A over b divided by c over d, we change it to multiplication and flip that second fraction, called the reciprocal. Okay, so then when you complete that, you should have AD over BC. Okay, let's go ahead and apply that here. Multiply or divide as indicated, and then simplify to lowest terms. 1/2 times 4/5. There's a couple of ways we could do this. We could just multiply straight across, and we get 1 times 4 is 4 over 2 times 5 is 10, and then we realize that can be simplified. We can take out a 2 on both of those, so be 2 times 2 over 2 times 5. Those cancel, removing that factor of 1, and we get 2/5. Okay? Or we could do it another way. The other way is to take the original problem and then we realize that you can cancel here. We have a top and the bottom here that has a common factor of 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. And then when we multiply straight across, 1 times 2 is 2 over 1 times 5 is 5. This is the method that we're going to use for multiplying and dividing the rational expressions when it has a polynomial in it. So let's go ahead and do all of our multiplication like this, where you cancel a common factor first, and then you don't have to simplify after that. This is division. So let's go ahead and use the principle that we had. We changed the division to multiplication. We flip the second fraction, and then we can multiply. Right now we see that we can have some canceling. 3 goes into 3 one time, and 3 goes into 6 2 times. Then multiply straight across. 2 times 2 is 4 over 1 times 1 is 1, so we just have 4. Multiplication of rational expressions. First of all, I want you to remember how to simplify rational expressions. You have to have common factors in order to cancel. So if we cancel and cancel, then we have just 1. Okay? Those both cancel as 1s. We have something like this. Then, let's see, we have an x plus 3 that cancels, and we have an x that cancels. So we're left with x plus 2 over x minus 2. Remember, you can only cancel factors, not terms. So if you want to be able to cancel, you need to make sure that these are factors or that you turn it into factors by factoring. But never, ever, ever cancel things that are being added and subtracted. It'll get you into trouble quick. Multiplying rational expressions is similar to multiplying fractions. So here, to multiply two rational expressions, we multiply the numerators and multiply the denominators. That is, if I have a over b times c over d, I multiply straight across AC and BD. And of course, B and D are non-zero. Multiply and simplify to lowest terms. And leave your answers in factored form. Okay, I want you to see here, we cannot cancel those x's, cannot cancel those x's. Why is that? Because x is attached to that 1 by addition, not by multiplication. So it's not a factor. It's a term. We do not cancel terms. We only cancel factors. So we just have to multiply straight across. We get 8 times x plus 1 over x squared. And since we can leave the answer in factored form, we don't need to multiply the 8 through the x plus 1. That is our answer. Here I'm multiplying two fractions. I have some common factors I can cancel though. We have a 5x plus 1 on the top and a 5x plus 1 on the bottom, and those cancel. I also see I have a 3x plus 2 on the bottom and a 3x plus 2 on the top. Those will cancel. Remember that those all cancel as 1, so our answer is 1 over 1, which is simply 1. Now we have another problem here. We can't cancel anything out of this fraction the way it is because it's not factored. We have to have factors in order to cancel things. We cannot cancel the terms. So we're going to go ahead and factor the top. The top is x plus 2 times x plus 2. And the denominator here is x minus 1 and x minus 1. And we're multiplying by x minus 1 quantity squared and x plus 2 quantity squared. Now I can cancel some like factors here. I have 2 x minus 1s on the top and 2 x minus 1s on the bottom, so that cancels all of those. I have 2 x plus 2s on the top here and 2 x plus 2s on the bottom here, so that cancels both of those. And just like in the last problem, it all cancels as 1. Division of rational expressions. To divide rational expressions, we multiply by the reciprocal of the divisor, just the same as we did in fractions. If I have a over b divided by c over d, then I rewrite it as a over b times, I change the division to times, and I flip the second rational expression so that it's d over c. And here b, c, and d are non-zero so that we have defined rational expressions. Divide and simplify the lowest terms. Leave your answers in factored form. We need to change this division into multiplication and flip the second fraction so that it's 2x over x plus 2 now. And right away you'll see you have a 2x here and a 2x there. You can cancel those since it's a common factor, and we're left with 6 over x plus 2. Now can I cancel the 2 into 6 and make that 6 a 3? No, I can't, because that 2 is attached to this x by addition, not by multiplication. We can only cancel things that are being multiplied, not things that are added and subtracted. So that is that final answer. Here, I need to do some factoring. I need to change this to multiplication, and I need to find the reciprocal of this fraction. There's a little bit of work to do here. Let's factor the first numerator. It's y plus 3, y minus 3, and the denominator is y plus 5, y minus 5. I'm changing the division to multiplication and flipping the second fraction so that it's y plus 5 over y plus 3 now. Then I'm ready to cancel if something can cancel. So I have a y plus 3 here that can cancel, and a y plus 5 there that can cancel, and that leaves me with y minus 3 over y minus 5. Again, I cannot cancel those y's because they're connected to the negative 3 and the negative 5 through addition or subtraction. Here I have some work to do. I'm going to have to factor the numerator and denominator here. I need to change this to multiplication and find the reciprocal of this. So let's start on the first rational expression. It is t plus 1 times t minus 1 And the denominator also breaks up t plus 6 and t minus 1. I'm going to change the division to multiplication. And just so you can see this better, this looks like it's not a fraction, but we can write it as a fraction by just putting it over 1. That way it's easier to see when we take the reciprocal of it, the 1 is now on top, and the t plus 1 is now on the bottom. Let's cancel anything that we can. We're going to cancel this t plus 1 with this t plus 1. And we can cancel this t minus 1 with this t minus 1. That leaves me with a 1 on top and a t plus 6 on the denominator. Now on this rational expression, we're going to have to factor. It looks like we have a difference of cubes on top and a difference of squares on the bottom. So let's get to factoring the numerator first. We'll have an x minus y, and the next factor is going to be a trinomial, x squared for the first term, y squared for the last term, xy in the middle. This will be the opposite sign from that, and this is always positive. And the denominator here is the difference of squares that factors as x plus y, x minus y. Division turns to multiplication, and I find the reciprocal of this just by flipping. Now I can cancel anything that can cancel. You can cancel this x minus y with this x minus y, or you can cancel it with this x minus y. It doesn't matter, but you can only cancel one time. One time and it's used up. So let's go ahead and cancel right there. And then I have this factor and this factor that can cancel. And I'm left with, quite simply, x minus y over x plus y. That does it for this lesson. Go ahead and try the homework, and be sure and email me if you have any questions.